Hey guys, welcome back. NJ here, and today I have with me a very, very special guest. We have Jonas, the designer of the OMP Hobby M4. Very lucky to have him today, Jonas. Say hi.
Hi, nice to meet you, Neil.
Nice to meet you too. So you're going to have to teach me how to say your surname, because I notice anyone that ever speaks to you online just avoids saying your surname. So please pronounce it for me.
That's okay. It's Wackershauser.
Wackershauser.
Yep, that's perfect.
There you go. Not too
But
bad.
you can just call me Jonas. That's fine
Jonas is
too.
good. Yeah, I'm a little ashamed to say my German should be a lot better. I spend so much time in Germany, and the sort of the main ones I have are things like Vegates, obviously, and the various greetings and ordering beer. You know, all the important things. Jonas. So for anyone that doesn't know Jonas, I'll be linking his YouTube video, his YouTube channel rather, in the description. You're probably all here because you want to know a little bit more from the man who designed the OMP Hobby M4. So let's just quickly talk a little bit about your background for people that don't know you. How did you get into RC helis, and how did this become, this sort of your career now?
This is a question that goes back to when I was so little. I was like not even 1 year old, and my mom always placed me under the ceiling fan in our living room. And I was like, yay, fan goes spin. And well, that then translated to helicopter rotors, and I've been obsessed with helicopters since I can think. It was full scale at first, but like that's completely out of reach for a kid. So my mom at some point started buying me like RC toys back in like 2005, 6, the first RC helicopters that you could commercially buy that weren't like super expensive or super complicated. And then one thing led to another, got more involved, got more professional, you could say. Then in 2010, I picked up my first collective pitch helicopter.
Do you remember what that was?
Oh, a Wackershauser 4G6. Blade length
Okay.
is somewhere in between these two, M1 and M2.
Right.
But it had a flybar head, a moving flybar head, if you know what that is. Flybar moves up and down with the collective, so you do not need a pitch compensator. And oh my God, this was the worst helicopter ever. But like, it was 1S powered, in-runner motor, completely underpowered, torque tube tail. You would crash it once, 50 euros of stuff would break. You would be spending 2 hours to fix it just to crash it again next flight because it flew so bad. But I learned to fly inverted on it. I learned to fly inverted circuits. I tried some TikToks, and then the MCPX came, and then that was the next step. It is so addictive.
Yeah.
It's like, I mean, look behind me. Like, what else can I say?
Yeah, absolutely. But that was a really interesting thing about the saying that your first love of rotary was actually a fan, just seeing a spinning blade above your head as a child. I think that's fantastic. One of the other sort of background things, obviously your collaboration with OMP Hobby is one side of things, but before that, this isn't the first RC based company that you've been working with. There's Rotortech blades, obviously.
Mhm.
Am I right in thinking AccuRC as well, the sim? You had some dealings with those guys as well. You did some work with them. So what's the story with those two things before we move on to OMP?
So I've always been a big fan of RC simulators for the accuracy side. And so when a new simulator came out, I was like, oh my God, I need to try this. I tried it, found some bugs, reported to the back then V1 team. Then they put me into the beta team. Then they eventually all bailed in 2017 when V2 was around the corner for company issues. And then they asked me, hey, do you want to work for us? And since then, I had been designing all the new helicopters for AccuRC, 3D modeling. I've been making the new workbench. I've been tweaking flight dynamics, that kind of stuff. I've never actually been involved with code. I've probably written like 2 or 3 lines of code for a very specific problem that I knew how to solve. But yeah, I've been a 3D modeling guy. I do not work at AccuRC anymore, but it was a great company. great product, definitely still my sim of choice. And Rotortech, that also was a fun kind of story. When they brought out the Rotortech 700 Ultimate with the orange tips, they were very interesting to say the least. They were spec'd in a way that was not flyable, to put it nicely. Just weight and CG were just wrong for a 700 blade. So I was flying these. I was like, oh my God, what's this? And the friend I was flying with was like, why don't you email Funky? And I was like, dude, Funky is a huge company in China. They are not going to reply. Just try it. It doesn't cost you anything. So I emailed them and gave them some detailed feedback on what I thought could be improved about the blade. And they got back to me. And they sent me some sets. They still weren't good. I communicated that. And then they sent me some more sets. And in there was the new master set for the 700 Ultimate. So we sent that to more team pilots. They all loved it. And since then, they've involved me more and more in the design process of the blades. 560 and 610 Ultimate, I have done the basic specs, nothing on the airfoil yet. Then came the... Good question. What came after the 610? I have to look over there. Probably the 580. 580, I actually got involved with the CAD design. Then the 385, I modified the airfoil to get more performance out. And then the 715 Ultimate and 420 Ultimate were basically entirely my design. I spec'd everything about these blades, including the airfoil. The Funky engineers just built the model, sent it to me for review, made molds, and the rest is history.
The rest is history. That's fantastic. Fantastic CV there. I mean, when you say that you got involved in the airfoil design, now normally when it comes to airfoil design, we're talking about fluid engine, fluid dynamics, and understanding the properties of airfoils. And is that something that you kind of learn on the fly, or do you have some background in that? How did you end up sort of looking at the blade as a whole to achieve what you wanted from it?
Let's put it like this. I did not study this. I have a bachelor in mechatronics engineering. There was one fluid dynamics class in there, but that does not teach you that. Basically a lot of reading in books. One person who was also very influential was Bill Whiteman from VTX. Great guy. Doesn't work there anymore, but I was involved with VTX briefly, and he taught me so much for blade design. It's crazy. I learned how to evaluate an airfoil, how to simulate an airfoil from him. He showed me how to kind of do the specking of or rather how he does the specking of his blades, and I could derive some methods from him. He was great for this. Otherwise, tons of experience with helicopters, flown basically all blades on the market, and at some point you just get an intuition for what you want in a blade and what you need to change in a blade to get it to fly the way you want. Like in a 700 blade, I can tell a 3-gram difference per blade.
Wow. Yeah, that's very impressive. I guess it's just one of those things. You do a lot of testing, and what's the process to when you've got a design that you're pretty sure is going to be exactly what you very close to what you want. Do you get prototypes sent then to test this stuff out, maybe with some variants, and then start nailing it down? Is that a long process?
Depends on the blade. Actually, I can show you the stack of prototypes for the 385 Ultimate that we fly on the M4.
Wow. Okay, it's an impressive stack of prototypes.
This is like 16 sets of blades.
Wow.
385 was quite the process. Other blades, we just need like one batch of prototypes. It all starts in simulation. I wrote a MATLAB script that can simulate the rotor as a whole. And I just punch in the blade parameters. It simulates it and spits me out a bunch of numbers that normal people probably wouldn't be able to understand, but like they make sense to me. And they give me quite detailed information about the rotor performance. Then we build the blade in CAD. I take the CAD model, I feed that back into my MATLAB script and simulate it again. And then they make a mold, build prototypes with different weights inside the blade to shift weight and CG around. And the funny part is, with this simulation script, I can actually predict the correct weight and CG to make the blade fly the way it should fly. And then I just tell them, get it to this, make some upwards from it in agility, downwards from it in agility, send me them. But usually the blade that's closest to my calculated spec is also the blade I pick for the masters.
Yeah, that's awesome. So I mean, that kind of detail for me, I think is quite important, because maybe it's something that's not as well known, but I think it sets the precedent for the whole ethos, I guess, of the M4. I can tell you're very obsessive about getting every little aspect of this from all of your experience to be the absolute best it can, but to also be involved in the dynamics of the blade, I think is well, I think personally that's hugely advantageous, because you're building the thing that they're bolting onto. You can make the two work together wonderfully. So I guess this now segues very nicely into talking about the M4. So first of all, just quickly, how did you end up with this relate? I mean, I can see a bit of a thread here. Send an email, start bothering people till they respond. I'm kind of getting that. Tell me about this OMP relationship, how that became a thing.
That actually developed from AccuRC. We got in contact with TJ Williams from the USA. He was promo representative PR guy for BuddyRC. He's now with Horizon. Wish him all the best there. Amazing guy, one of the nicest people I've met in this hobby.
I've seen his channel. Really super nice guy. Very informative videos as well.
Absolutely amazing. And he got us in contact with OMP directly, with Jeff, my boss, also one of the nicest people I've ever met in this hobby. And then we got CAD models for the M2, put that in AccuRC, got CAD models for the M1, put that in the Alpha, and then TJ was like, hey, you fly a Logo 200, do you want to try an M1? And I was like, sure, and they sent me an M1, and I loved it. And then he was like, hey, do you want to try an M2? And then he arranged this from China directly also, got an M2. Also absolutely loved it. Fun fact, I got this M2 V2 here. And then my Logo 200, got 4 more flights, and then I gave it away.
Interesting.
Yeah, kind of fun story there. And how I got so closely involved with OMP was, there was one guy that was emailing Jeff about an issue with the M1 where he would do collective pumps and claimed his tail would step out. And Jeff asked me to reply to him because that guy would not back off. And Jeff did not have the expertise to answer this, so he related to me. I took my M1, took the transmitter, completely locked out the yaw channel to make sure I did not accidentally give any yaw, and then reproduced exactly what this guy was like showing in his video. And guess what? My helicopter didn't do it. I gave Jeff a video. And I gave Jeff a video of this. I gave Jeff a detailed explanation of what I did. The guy never mailed back.
Of course he didn't. No, it's like I'm sure he got his transmitter and he was tightening up the spring on the back to make sure his yaw wasn't stepping out. Yep. Yeah, it's so funny, isn't it? There's so many little single things that you can just overlook. You've got to be very objective in this hobby to try and decipher when you run into problems, because sometimes they're very, very simple. They can be complicated, but sometimes they're very, very simple.
Yeah. And then
carry on.
Yeah, I was not done yet. And then Jeff knew that I had like problem-solving skills, that I am an accomplished pilot who can actually reproduce things, and that I can give detailed feedback on things. So he then told me, hey, we're going to make a new version of the M2. Do you want to test the prototype of that? Which ended up being the M2 Evo. And then he sent me a prototype there were some things wrong with it. I gave feedback on those. We improved those. He sent me a second sample, got better. And then eventually we arrived at the M2 Evo that's on the market now. So this also includes my work in a way, that I gave feedback that substantially influenced the way the project went. For example, that whole big tail prop, tail motor combination was my idea. Longer blades, bigger battery, all that basically came from me.
Can I ask about just from a personal observation, your
Yes.
move from the DFC style head to one with the washout arms back in? So was that your decision, or was that something that was just a general consensus? Let's move away from DFC, because I guess you have that teetering problem with DFC, don't you? Where,
Yes.
because I've always found with DFCs the problem tends to be that you narrow the sweet spot for rotor RPM, whereas if you go away from DFC, you can have a much larger range of RPMs available.
Yep. Let me just demonstrate this real quick. So if we take this M2 and look at the rotor, you can see this unit of blades, grips, spindle going through the head, and that's suspended in 2 rubber dampers. And the DFC is a rigid arm that bolts in with a screw. And that's the problem with DFC. If the blades try to flap up and down, you're actually putting lateral pressure on the ball joint down there. And that's the biggest issue. It constrains the entire disc from flapping and it wears out these ball joints.
Yeah, it makes total sense. And I guess that's why you end up with, sometimes I've found with DFCs, it's usually the lower RPMs where things get really terrible.
Yep. It actually wasn't terrible on the M2. There was a very, very narrow band around 4,000 and 5,000 RPM where this was an issue. But the bigger issue is if you fly this helicopter hard, the old M2 with the DFC head, every 200 flights I had to swap my DFC links because they were worn out. So yeah, we changed to the normal flabberless head for longevity and for solving that wobble issue. And it worked. The real quick, the wobbling comes from the fact that if you constrain the flap of a rotor, this also happens if you put very rigid dampers in. So that's also the reason why the M4 has large rubber dampers instead of POM or something, Delrin. If you constrain the flap, the actual blade flap happens out in the blade, and that shortens the phase of the rotor. Normally it's 90 degrees. But if you flap out here, it shortens the phase to maybe 80, 70. It's unpredictable.
Right, that's very interesting.
And from that, you get that wobbling because it's
a gyrating, isn't it?
It's kind of a gyrating oscillation that wanders around the disc because the disc is never actually in phase to flap away that error.
Yeah,
that's wobbling you're seeing.
That makes sense. That's a really good explanation. That's why I love this hobby and all things helicopter. You just learn new things all the time, and that's brilliant information. So what were what was the concept of the M4 for you? Because we now let's move on to what I assume is now this is your baby. So so how did this come about, and then what were your concepts?
Okay, so Jeff asked me to design a helicopter because at that point he knew I had proficiency in all the things you need to design a helicopter. And he was like, okay, we need some fresh wind in our design department. Why don't you do it? So I first discussed with him what size. And I've always had a love for 380s because they're big enough to fly really, really good if they do. But they're small enough so you can carry them in a backpack. And with the 385 Ultimate that we have, it was kind of a no-brainer to make this helicopter happen, especially because direct drive still works in this size. And we wanted a new direct drive helicopter. So we decided on 380. And the entire design philosophy with the M4 was that I took things that I did not like about other 380s and did not do them on the M4.
It's kind of a reverse concept.
Yes.
We take all the things we don't want, and whatever is left is now what's going to be in this. I mean, that works. Totally works.
Yep. It really turned out more amazing than I could have ever wished for. Like, when I look at early design concepts and CAD models, I started this project on the 17th of August, 2022, and had the first prototype flying sometime in November, I think.
That's pretty quick, Jonas. I'm not going to lie. For how long these things can take to develop, that's some dedication. I imagine you've sunk an awful lot of hours in to get things moving.
Oh yes, and like I still have that heli. Wait, it's actually here. This is the prototype, the EVT prototype that you saw in so many videos.
Wow.
And the amount of parts this helicopter shares with the final product is like 10%, 20%. We changed so many things because like you get the initial design flying, yes, but then you think, how can I make this better? And then you change so many things. Like one detail I can show you, blade grip arms. Huh?
Yeah.
They bolt into the blade grips, but on this one, the screw actually came through a hole on the other side and went through the grip. And I was like, okay, this looks neat and all, because it looks neat, also with the cutout in here. But if you crash and need to change this arm, it's gonna suck. So we changed that to screws on the outside. We changed the sizes of the cutouts in the rotor parts. We changed the rotor geometry slightly. We changed the tail a bit. It's just so many things. You can also see this motor has a completely different fan design. This was a radial fan instead of an axial fan.
Wow.
It's just it's crazy.
Yeah, that's quite incredible. And when it comes to the motor, did you talk to SunnySky directly about sort of the numbers and what you were trying to achieve with that, or was it something that was, very, very quick to get together?
Oh yeah, SunnySky and OMP are owned by the same shareholder basically.
Okay.
So they are kind of one and the same company when it comes to these kind of things. So it was super easy to communicate with them. We actually discussed a lot of motor sizes. We started out on like 7206 and then went up to 8108, 8109. It was kind of a process of experimenting and calculating. They have a whole team dedicated to propulsion engineering. So they actually kind of took as reference industrial quadcopters, which can have similar rotor diameters to this, and looked at what power do they draw, what kind of motor do they need. And SunnySky has the M8 series, which is actually the same stator size as the M4 motor.
Okay.
So we took that stator and built a helicopter motor around it.
Right, very interesting. Because I mean, I've had a little bit of time since building the. The build has taken me 3 times as long as it normally would because I've got a camera in my face whilst I'm trying to do it. But there was a few things that dawned on me. One was I kind of thought, right, what's the next thing to do? And I was like, oh no, I've built it. It was it's great to see a low part count helicopter for lots of reasons, including less parts usually ends up working out a lot cheaper as well, less downtime, but also the fact that the kind of the biggest thing from flight testing it and messing around with the different RPMs you could run it at on a 2200 milliamp 6S like a 50C. I was hovering it and I thought, let me see how low I can get the RPM, just because I want to know. This still feels agile. Like, why is this still so agile at low RPM? And I brought it all the way down to 1500 and still, like, everything. And I know some of this is the blades as well, but it was amazing that I was able to do that. I did it for like 12 minutes and then I came upstairs and I thought, let me put some charge back in the pack, and it charged it back, and when I checked the voltage, the cell was at 3.82. I was like, what? I still had so much time. I was just incredible. You see people running this above 3,500 RPM in some instances, and then you can go all the way down there and still it's great. I mean, what an enormous envelope. I don't think I've flown any helicopter with that kind of envelope, which I think's amazing.
Yeah, this is something I'm very proud of, because like, if you've ever watched my YouTube videos, you know I use that entire envelope. I am a low RPM pilot, a high RPM pilot. It's like, I need this envelope to be happy, because one battery I might decide to cruise around for 12 minutes. Next battery I want to drain it down in 2 minutes 30. And like, just having that possibility, which is 50% blades, 50% rotor geometry. Yeah, this was a no-brainer to incorporate this. Oh, and also the tail, obviously. The tail is completely overpowered. It's stupid.
I was about to say this, the tail, because again, this is just from, 25 years of building and crashing and seeing RC helicopters evolve. The one thing that is always my nightmare with any helicopter when I first go to fly it is the tail going to be as good as all those sponsored pilots flying them in the videos for promotion? Because there's been plenty of times where you'd get, and this isn't just exclusively down at the cheap end. I've flown and owned some incredibly expensive helicopters. I won't drop names, but there has been some very premium models that I have had no end of tail problems with, and it's not a case of user error. I've been doing this a long time. I know exactly what makes a good tail and how a good tail should feel, how it should feel mechanically, how it should feel from a balanced static and dynamic point of view. I understand these things, and I know when it looks right and when it sounds right and when it feels right. And it's just the fear. The worst thing it could just ruin your day if the tail is sloppy or constantly hunting and you can't bring it back to being a problem with the flight controller. And then it could be mechanics. So you start upgrading. Let me get the metal arm for this, and let me get the upgraded red coloured anodized thing for that. And maybe I'll move a ghost oscillator. There's like a resonant frequency that's causing problems in just my model. It's just me. And I've been there so many times, and this was just a delight, straight out of the box at all RPMs. I could tell this is a tail with, and you can see it as well, this tail has lots of authority, and with the PNP kit I got, it's matching great with that servo, but the mechanics feel great as well. I can see there's been a lot of love put into that tail. So tell us a little bit about the secret sauce with that.
The secret sauce of the tail is that, let me think. I actually need to think. Wait, cut this out. How do I not breach my NDA?
Oh, right, I see. It's that kind of secret sauce. So the pitch slider looked quite large. I noticed that. There seems to be good leverage on the pitch slider.
Yeah, I will actually show you. Okay, so the secret sauce with the tail is, for one, that it's huge. Like, the entire rotor is like gigantic. And then you have this really long tail shaft, so that the slider actually travels a long way for the pitch angle you get. 380s have always been difficult with the tail, because like, the designers of other helicopters never give the tail this throw to articulate. And the secret in this tail is to minimize the slop in the blade. You need to think about where the slop comes from, and it's usually not rotary slop. So rotating parts are pretty well constrained. They do not have slop. It's usually linear parts, the linkage, the slider, that kind of stuff. And by changing the relation from linear throw to angle on the tail blade, you can minimize the impact of linear play. So, for example, there's another 380 on the market on which you can grab the tail blade, wiggle it around, and it will move like 10 degrees or so, because just of the play in the mechanics. And that helicopter has a third of the tail throw per side on the tail rotor. So by just increasing this throw by 3 times, if we had the same amount of play, you would end up with a third of the play in the blade grip. And like, This is a tail that has kissed the ground so many times. I've crashed this helicopter like I stopped counting because I usually just test new things on this one. And if I wiggle this blade, like, where's the slop?
None. Yeah, I can see.
Yeah, this helicopter is like one. It doesn't even have the production motor in it. It still has a motor where the stator is flipped and all the wiring runs on the top, and it's still in this fantastic condition where it's like just slop free. It works just so well. Like, you can tell I'm proud of this tail because it just works from 1200 RPM where it barely hovers up to 3500. Hell, I have tested this to 4200. Don't tell anyone, this is not allowed.
Wow. Yeah, that's some scary territory. Yeah, I mean, yeah, absolutely agree that the tail is just one of the greatest things on that helicopter. And yeah, as I said, just from as I built it and felt the mechanics, and you know, because as soon as you build a tail, you start twisting the blades to look for slop and see how things are. And again, it was, yeah, as you've demonstrated, just built with such precision, and to obviously this is all engineered to a very high tolerance as well, which is fabulous. So what else did I want to cover here? So yeah, I mean, going back to something you said about the size, of all the different sizes of helicopters I've owned, my favourite helicopter, actually, which goes back quite a way, or the one that left an impression on me, I should say, was the very first version that Align brought out of the T-Rex 500, which wasn't actually anywhere near a 500. It was much closer to a 4. And the reason back then, V-Bar had come out with their first, they were very early days V-Bar, and I had one of their little black box V-Bars units, and I bought a conversion head for that, and that helicopter was brilliant for all the right reasons. It ran off one 6S pack, which you could, you know, they were cheap, you could buy lots of them. The whole thing was just that right size where you can throw it in the back of a car or on a backpack and cycle somewhere with it, but it was at that size where in many ways it just behaved like the bigger guys. You know, it not only that behaviour, but it had the presence. And I think that's probably the other thing as well. There is something golden about that size of helicopter where it suddenly has presence in the air. And I think that 380, 400 size is where that is. And this was why specifically I was so excited about the M4. I was like, I already had the M1, M2, a couple of M2 V2s for which, you know, I worked on a tail for, and then the M2 Evo. And when I heard about the M4, I was like, this could be the replacement for that size of helicopter that I really wanted. So yeah, I think and as soon as I flew this, I was like, yeah, it's exactly what I wanted. It's back in that magical size for me. But I mean, I don't know, because you fly all different sizes of helicopters. Is that a particularly appealing size of helicopter for you as well?
Let's put it like this. I started out with after the 4G6, I got a T-Rex 500 ESP. So also that 425 size.
Yeah.
And you're right, it was brilliant. Just outdated now.
Yeah, exactly.
380 is a bit smaller, but I can spoil that much. If you like the 380 M4, we might have something in the future that's gonna tickle that itch just right. Just right.
Well, ladies and gentlemen, you've heard it here first.
This is one of the things I mentioned earlier, that I was just out testing on the field. Right. I've also put some Instagram stories where you could basically have it in plain sight. Just
people, so that's good to know. We'll
the guys on the Rotor Flight Discord have a pretty good lead. The heli is over there. I can. I'm gonna flash it to the camera real quick.
Please do.
Just like.
Okay. Very interesting. Very interesting.
Yes, that's okay. Like. Let's put it like this. I don't want to fly anything else anymore. This is the greatest thing I've ever done. And
wow.
Like,
You can't say that yet, Jonas. You're still in promotional stage of the M4.
Yeah, I mean it's still an M4. It's still an M4.
It's just maybe it's slightly stretched brother, is what you're saying, perhaps.
Maybe slightly modified. We will see.
Now,
See.
let me think. If this was slightly stretched, it'd probably be. Where would we go to? And this could be more of an auto-rotation machine as well, right? Gauge the look. Gauge the look.
You are right up against the bounds of things I can say.
Okay, well, I won't push you hard on that. I think we've got a lot of exclusive stuff here, for which I'm very grateful.
Oh yeah, and that's not the only helicopter I've modified. There is another one in a completely different direction, but it's also freaking amazing, and I love it.
Excellent. Well, Jonas, I certainly hope you'll be back here to tell us more when you're allowed to tell us more.
Surely.
That's amazing. So, in terms of the M4 as well, let's go back to the heli of the day.
Yes.
How has it been in crash testing? So I know it's difficult with a new helicopter to really have too much of an idea until you have lots of users put in. But I know that, well, from the Heli Freak forums, I know you've been quite honest about the fact that you've put those through quite a lot of punishment, your models.
Yeah, I mean, crash testing, we do not do it deliberately. It just happens. I did not once did I crash the original EVT prototype, and it's gonna stay that way. It's not gonna fly again. The first crash test of a production model just installed a new flybarless system. We were at Rotor Live. First day was over. We went to a nearby field because some pro pilots wanted to try it. And that new flybarless system crashed my helicopter. It went full deadlock on the tail at 3D head speed, full left yaw, and it just rotated 5,000 degrees per second into the ground.
God. Is there any video footage of that?
I do have that. Yes.
You really should upload that. I would love to see that.
Yeah, the YouTube title starts with "Do not share."
Yeah.
Like so many of my prototyping videos. But yeah, the heli came out with some damage. It killed the canopy. That was like the biggest issue because we did not have enough canopies for Rotor Life, but I had all the spare parts to fix it. And in the end, it was like a bent boom, the canopy, servo arm stripped, canopy mount broken as it should, a skid, blades obviously, but like I have all the blades. Next day it flew again. We flew demos with it.
Fantastic. Yeah, I mean, I'm sure you, like myself, have been in a place where even the lightest of crashes has resulted in hundreds of dollars of
yes
of repairs. So and my experience with crashing the OMP M2V2. I mean, I know we're talking about a different point of inertia and weight and with the M2V2, but it was another example of where most crashes, and actually there's a crash on my YouTube channel where I just go sideways straight into the ground. I walk over, pick it up, spin it up in my hand, and I'm like, this is still completely balanced. Like, why is it not even vibrating a bit? And then just go flying. But yeah, I've absolutely no doubt. Obviously, it's nice and crash worthy again. Being able to get back up in the air, it's a big part of it now, I think. And when you say tripped the servo horns, I think that's the best way to think of them, isn't it? The servo horns are like fuses.
Yep.
And that's again just a great idea. That crash inertia's got to go somewhere. Put it into a part that's cheap, that will designed to break, so expensive bits don't.
Mm-hmm. There's actually a lot of these kind of parts scattered all over the helicopter. Like, we have obviously the servo arms. They are made to strip the spline and brake. So if you crash, these go first. Blades, I mean, you cannot crash without.
That's part of the game.
Yeah. Skids, they are flexible to a point. They are very impact resistant, but if you impact them too hard, they will snap and take a lot of energy out, because that snapping in itself absorbs like
quite a big amount.
probably 80-90% of the impact. The tail boom actually is sacrificial. This profile is very rigid in flight, but if you smack on it, it will bend in a controlled manner. We have actually never ripped off an M4 boom. They just bend and keep everything attached, so the belt has a good chance of survival. To safety tail mechanics, because like tail mechanics are a pain to rebuild because it's also finicky. And if you're like say out in the field, have a field day, crash and have a new boom with you, you don't want to swap all that stuff back here. So that smack just goes into the boom, breaks the boom, tail mechanics have a better chance of staying intact. Then also the battery tray. We do not want the battery to explode. So if the battery gets a smack that is strong enough, it is actually designed to snap out of the battery tray and save the battery from like deformation and explosion.
That's a good idea. So is that why the rails are quite thin on the battery trays? It's so it can pop out of the...
Oh, you just reminded me. The crash I described was not my first crash. The first crash was like when I was setting up the helis on the field without a canopy. I used a 3D printed tray because I was dumb and did not have enough of the proper trays. And the battery ejected in flight into the blades. Oops.
Oh, wow.
I do not have video of that, but like it was 3 days before Rotor Live, and I was devastated. But it broke blades, servo arm, a boom, and the battery that impacted the dirt path 2 meters besides me and burst into flames.
Wow.
Yeah, we have improved the battery tray since then. First, do not use 3D printed trays. Second, we increased the engagement to a point where it absolutely cannot eject in flight, but will still do the kind of eject out if it gets a smack in the crash.
Do you know what it reminds me of is how ski boots work, where they lock into the skis and they're incredibly rigid, but in a crash where they might twist, they're designed to pop out and not break your leg. So perhaps a similar kind of thing. I did actually just get in the post those exact things for more batteries. They literally came just before this interview started. But I mean, with the M2, I did actually print battery trays for that because I just have hundreds of batteries for it.
Yeah,
but which I think is fine on that.
Yeah, sure. I mean, some people also ripped off the latch on the frame and just slide in the battery, put the canopy on. It's fine. Small helis are easy to handle and that kind of stuff.
Yeah. So a couple of questions that I've got for you. So one of them is in terms of these are just sort of observations of watching your videos in terms of RPM management. So I literally copied your setup. I've moved over to the MSH brain, and I think you can see my M4 behind me here. So I did the brain and the RXSR with F-port telemetry, and that's all working really well for me. And I'm flying on banks, but I noticed you change RPM. Like, are you doing it by a dial? Are you using like one of the rotatory?
Nope.
So how do you change RPM on the fly? Are you just on banks?
Oh, you mean that one video where I was like, oh, we're gonna do a flight at I don't know yet RPM, and then I change it up and down, and I'm like, oh, 2150. That's a feature of V control. That was with V bar.
Right.
You can put stuff on a dial there, but you can also do that on HTX and tune it on the fly. But yeah, I just have my 3 position switch that switches between my 3 RPMs.
Right, got you. And do you have a preference when it comes to flight control? Because I know you fly all of these different flight controllers, and you for testing and for helping others with their different setups, I know you're trying out a lot of different gear that you might not necessarily favour. But is there one or two that you would favour, or are they all kind of performing the same these days, some of these top brand ones? What's your feeling on that?
I'm gonna say these days you cannot buy a bad fiberless system anymore. They all work wonderfully. From what I've seen, they all can handle the M4 just fine. V-Bar, Brain, Spirit, Micro Beast. Even this helicopter's on Rotorflight now. You know Rotorflight?
Remind me. I know the name.
the beta flight fork for helicopters.
Ah, right, of course. Yes, I do know.
Yes,
I do know.
I've joined their Discord. I've put a quadcopter flight controller in this. I have tuned it to the level of any other flybarless system within 2 batteries.
Wow.
It's
And
incredible.
is that on an F7 flight controller that you've just flashed with? I mean, is it literally that?
It's an F405.
It's an F405.
Doesn't even need that much, and it's not even the best gyro chip in there.
Right. So, ladies and gentlemen, for those of you that don't know what these kind of flight controllers are that go into drones, we are talking about a flight control board that is probably £15, maybe £15 to £20 for it's, yeah, exactly, goes straight in.
Yeah, something like that back here.
Yeah.
Yep, that's literally it. You can slap that in, solder on some servo plugs, and
yeah. So if you're handy with a soldering iron and you're happy to do a little bit of the work yourself, then that is an incredibly cheap option compared to the more expensive stuff like Brain, certainly V-Bar and the others. So that's really interesting. We must chat at another time more about that, especially if you're involved in it. That sounds very interesting. And so far that's been very promising, has it, in terms of performance?
Yeah, absolutely, it's insane. I actually also have tried this on an M2. Flies amazing. You can tune it to a degree that's like the Logo 200 exists, and Rotorflight outperforms it in every single way.
Wow.
It's madness. Shout out to Dr. Rudder and the other guys who develop Rotorflight. It's crazy good. Like, I am actually considering switching all my helicopters to it right now. I'm not quite sure, but the communication with the Rotorflight guys and the level of discussion you can have with them, it's just so pleasant to work with them. We implemented the OMP ESC telemetry in Rotorflight. It was done in a day and a half and was working. Dr. Rudder especially is such a competent person in this hobby. We need more people like him. Like, solely for this competence that he shows in his Discord server and the openness to suggestions and to ideas and working with the user instead of against the user. That alone makes me want to switch everything to Rotorflight right now. He's amazing.
That sounds very inspirational, and that's really great to hear. I mean, the fact that, again, it's making, well, it's about the accessibility, isn't it? When you, especially if you can run it on a cheap F4 flight controller, which are hardly cutting edge anymore, the F4. In fact, I'm not sure if Betaflight still support F4s, because I know that every so often you get this generational jump where they stop supporting newer versions of Betaflight, stop supporting certain older hardware because they run out of it hasn't got the processing power to deal with some of the features. But if this is running great on an F4, yeah, I mean, you literally like 15-20 euros and you've got a flight controller that can give you a level of performance that is being endorsed by Jonas right here. I mean, that's that's quite impressive stuff. Yeah, we must talk more about this at some point. That sounds really interesting.
There's only one word of warning I have. I have these quads hanging there, but I haven't flown them in like a year or so because quadcopter electronics are just not reliable at this time. I've told myself I'm not going to touch this stuff and put money into it until 2025 in the hopes that they at least get a bit more reliable. And I also had one flight controller just straight up die. Voltage regulator died, gyro chip not recognized anymore, servos jittering when setting up Rotorflight, so I had to go to a backup. So that's the only issue I have, that the quadcopter stuff is just so low quality and so susceptible to failure. But otherwise, if it works and when it works, it's amazing.
And do you think some of that is just because it became such a big fashionable thing, it exploded, and then it was just mass produced, and the quality of what was being mass produced has brought it down, or do you think it's a mix of things?
Quadcopter component manufacturers are putting more and more clone electronics in it.
Right.
Because we had a massive chip shortage. We still kind of do. And they want to sell stuff, so counterfeit voltage regulators, counterfeit MPU 6000s, all that stuff goes in there, and then it stops working, and people are like, why does it not work? It happens.
Yeah, and the other thing, I guess, is that will make people hesitant on that fact until we have more, the reliable electronics from a brand we can trust. Is that most quadcopters, when they fall out the sky, they bounce, and you just, even if they're upside down, you flip them over and off you go. And helicopters, whatever you're doing, it's going to cost a few more dollars than that. So and obviously there's the safety aspect as well. I'm not saying drones aren't dangerous, they certainly can be, but when we're talking about spinning carbon blades, it's another thing. So yeah, that's definitely interesting stuff, and yeah, super excited to hear more about the development of this.
Yeah, and let's put it like this: with the recent dilemma one major flybarless unit is having, this is not less reliable than that. So you might have heard about it. I'm not sure if you have.
A little, yes.
But you're now advised to take the lid off and hot glue pot the IMU inside the case to get it out of some resonant frequencies. Oh God, it's a mess. Maybe just do not use an ICM 2649 in a helicopter. But who am I to know this? Just my opinion.
What can you do? I mean, that's one thing for the certainly with RC helicopters, RC drones. There was so many ICMU testing that was done across all the different types to see which behaved the best. There was a lot of data on that. Not saying that there wasn't with helicopters, but there was just obviously that explosion of drones that became a real thing, and we definitely quickly found out which the bad ones were, because they became untunable and quite horrible to fly. But
signal to noise ratio, vibration performance, sensitivity to vibration, internal filtering, all that kind of stuff. We know which ones are the good ones, so there's no excuse to use anything except for those.
Yeah, absolutely.
People should pick the one that suits them best. They should not go by my, I've been using one system for all of eternity, since I started flying. So that's just been habitual. But other systems fly just as well. Now seeing Brain and Rotor Flight, I'm still trying to get a Spirit GT. All these things can be made to fly equally well, I'm convinced. And if people do not want to pay big money for the biggest brand in the sector, they don't have to, because with integration with HTX and some Lua scripts, you can get the same functionality as that one stupid expensive system that you kind of have to lock yourself into. And with HTX transmitters, you're having the most recent and most up-to-date transmitter hardware and software that you can get, and it's great. I would actually advise people to go the HTX route with a flybarless unit that supports Lua script programming, because it's just so convenient and does not cost thousands of whatever you're.
I mean, I'm on a TX16S with EdgeTX, have been for a while now, and I switched to EdgeTX when it was just when it just showed up, purely because I was so excited to have touchscreen functionality. But then I never left. I just thought actually, and it just got better and better, and as you say, with the Lua script functionality now, allowing you to adjust stuff on the fly, and not needing to spend more money on Bluetooth modules and proprietary apps. It just does everything I need it to, and it gets better with every update. It's another team that are just obsessive and doing great things, but it's amazed me how good the EdgeTX is now, especially paired with a TX16S. In fact, I'm actually selling there's my T-Rex 500X. I'm getting rid of that now, the M4's here, because that just doesn't do anything for me now that this guy's here. But that's all V-bar, but I don't know why. I've got the V-bar with the smaller screen. I haven't got the large V-bar radio, but there's something about the way that feels, that handset, that just I can't put my finger on it, and it's subjective. It's just me, but I don't get on with that radio from a feel point of view and the switch locations as much as I do my TX16S. I just, for some reason, that radio is just more comfortable for me. Strange how things work, you know. But again, there is always subjectivity in these things.
Do you want to know what the most comfortable radio is that I've ever tried?
Go on. Oh, so do you fly thumbs or you pinch?
I pinch.
See, that's unusual because I'm a pincher as well. But most pinchers say, "Oh, those controllers don't work for hand." But you actually like the game controller, but still pinching.
It's insanely comfortable. Just the way it grips, the way it lays in your hands. Even this kind of slope is more comfortable than a straight side box TX.
Yeah.
And the whole, I can reach every corner easily. I have relatively long sticks on it to make the gimbals feel larger than they are because they are micro gimbals. But this radio is the greatest value for your money that I have seen. It's got all the switches you need. It's got rotary dials. It's got great sticks. The sticks are actually honestly great. And these are not
sensor as well?
Yes, they are Hall sensor. They are not even AGO1. They're the standard plastic gimbals, and I love it. It's the big screen on it. You have everything you need on this radio.
And it goes in your backpack. You gotta love them. Well, I mean, I've got I had the X-Lite that was sent to me to review, quite a while back now, and I did love the X-Lite, but the screen was super tiny on it. And then I had the TBS Tango, which was obviously more for the long range stuff, but that was a great handset, much more premium feeling, but again had its quirks. But that one I haven't tried, but maybe that should be the next radio I look at on the channel.
Yeah, Tango 2 is what I had before the Zorro. And Tango was okay. Zorro is better.
Really? Interesting.
Much better.
I should definitely.
Ergonomics, sticks are better, screen is much larger. Obviously built in 4-in-1 module instead of Crossfire. I just use the Tango for these guys if I decide to fly them.
If you decide to go droning once in a while. I'm the same. Just now and again I'm like, I think I'll go out and fly the drone.
Yeah, TX16S I mainly just use when I'm actively tuning because the screen has just a bit more real estate than the Zorro screen and I can get more parameters on it. But otherwise, I use them basically interchangeably.
That's really interesting. Wow. Other question that I had about the OMP M4, which was in terms of auto-rotation. So this was the only thing with some of these smaller helicopters that they can be more of an arrival with such sort of low blade inertia. I mean, how would you rate this on a scale of 1 to 10 in terms of ease of auto rotation and things like overspeeds and acrobatic autos? What are you or 3D autos I should say, what are your thoughts on this?
It's a 380. 380s do not auto grade. They never have auto grade. I'll say 3 out of 10. If you can auto, you can do normal autos, you can do inverted autos, but that's about it. The modified M4 that we talked about, I've done some more fancy autos. It autos way better, I can tell you that. Hint, hint.
Yeah.
But the 380, don't bother.
Yeah.
Do not try to practice auto-rotating on it. It's just the nature of the heli size. It's pick a bigger one.
Yeah, that makes sense. Or should we say wait for a bigger one? It's just between you, me, and a few people out there on the internet. Don't worry.
A few thousand people, yeah sure.
Okay, that's fantastic. All right, well, thank you so much, Jonas, for joining me and chatting about the M4 and a whole bunch of stuff and some exclusives. This has been absolutely fantastic. You really must come back when you've got some more exciting news to tell us. But yeah, to everyone out there, don't forget to subscribe. I will leave a link to Jonas's channel as well, and also to the HeliFreak forums where you'll find myself, you'll find Jonas, you'll find pretty much everyone that we've talked about and lots more. That'll all be in the description. So thanks very much, Jonas. Thank you very much.
Thank you, Neil, for having me. It was a great pleasure to actually get to talk about and discuss design aspects of my heli without having random people on the internet speculate about it. It's been great. This has been fun. I cannot wait to see the result.
Excellent. Well, we shall definitely do it again. Okay, guys. Thanks very much. See you soon.
Bye. Thank you.